Hello, everybody. Thank you for joining the session. My name is Gregory. I'm very proud to participate at TheiaCon today. I'm a postgraduate researcher at the University of Huddersfield, and today I'm going to talk about visual DSLs in Eclipse Theia with GLSP and Langium. So, what exactly do I mean saying visual DSL? It's a language that can be edited both in text or in other visual representation. The language model is derived from the textual language and can be presented in other forms, such as on a diagram, or using the validation rules defined in a DSL grammar. All my presentation, I will often use an example based on the task list language you can see on the screen. This primitive domain-specific language lets the user specify tasks and put them in a sequence with transitions. So there are certain advantages of having text-first languages with multiple representation. First, being a text-based language, they integrate easily with development tools. For instance, diff for version control system Git for such a change, like adding one task and one transition, in DSL will look pretty straightforward and compact. In comparison, storing the same model in EMF JSON will require this kind of a monstrous change, because EMF stores not only semantic information, but also coordinates of nodes in the diagram, their sizes, and semantic identifiers. From the other side, since both representations are fully editable, the user may choose a more convenient way to edit the model. For instance, there are problems with UML class diagrams because they become too cluttered when the amount of classes go high. Here we can help by switching to text representation and adding the source directly. Since I plan to create a tool to combine textual and visual representation, obviously I need first to package them in an IDE. There should be code editor and diagram editor together. Language server protocol is de facto standard for textual languages, so the aim is to develop a model server based on the language server, and let the diagram editor to read and update the model. First, I went by overviewing existing solutions. In 2018, on EclipseCon, there was presented a Sprotty diagram based on the XText language server. The idea here is simple. The diagram generator is injected into the language server, generating the data model for a diagram and sending it straight over to Sprotty via the same LSP as for text editing to visualize. Unfortunately, the diagrams had limited editability because Sprotty itself doesn't provide infrastructure for diagrams editing, just for mere visualization. Also, it only communicated with language servers through actions protocol, which is also limited and not initially designed for graphical data interchange. Also, since diagram server is tightly coupled with language server, it restricts further extension by providing new representation of the same language model. Another solution was presented in 2018 is EMF Cloud Model Server. This is a more centralized approach where EMS stands in the center, connecting to other different components, which adds their own representation of the same model. Unfortunately, the source of truth here is not a DSL textual language, but an EMF JSON, which makes it not suitable for our use case. Lastly, in 2022, the ABIA presented interesting idea of combining Zero's web platform with Langium. This is really much closer to what I'm doing now, because it uses the Langium AST abstract syntax tree as a source for a model sharing with Zero's backend, which in turn visualize it in Explorer view or diagram view or whatever else. And backwards it also works, because Zero sends via GraphQL API updated AST model to Langium to update the textual presentation. Unfortunately, source code of the solution is not available, and typically Zero's web is also based on the EMF. So, coming to my own implementation, another step is select the technologies. For diagram editor, I was choosing between Obio GSP, Sprotty, and GLSP from Eclipse. Obio solution seems to be abandoned because it has not been updated for 6 years already. Sprotty, as already discussed, is rather a visualization tool, not a graphical editor. So the choice is obvious. Language server, I compared 3 alternatives. IntelliJ NPS is actually not a language server, but rather it provides you an entire workbench for rich textual editing and giving some freedom for other representation. Unfortunately, it does not support diagrams. So choosing between XText and Langium for language engineering tools, I selected the Langium because it is faster and it is not dependent on Eclipse meta modeling framework. For the IDE, I chose Theia because it is not only a cloud-native IDE platform, but also it provides you a compatible access to the versatile marketplace of VS Code extensions. Consequently, Monaco has been used as the default Theia code editor. So the ultimate technology stack looks like that, with Monaco and Langium for text editing, GLSP and Sprotty as its visualizer for graphical editing. The following changes has been addressed designing a Langium Model Server, which I call the model server based on Langium. First is how to create a model actually based on the Langium document, based on the Langium abstract syntax tree. Second is to expose an API which would let the consumer to read both synchronously and asynchronously model updates from the LMS, which is Langium Model Server. And lastly, how to apply external modification to the source, which is textual language. To create a model out of AST, 2 additional phases has been added to Langium document workflow. First, validator was customized not only to apply the validation rules based on the grammar, but also to filter out AST nodes which are invalid from the model server perspective. For instance, if there is a duplicate name or unresolved reference. Second step is to associate unique and unmodifiable identifier with each validated node to track its changes over time. So for validation, giving these simple task list constructions for, let's say, activities of researcher, the following AST is generated by Langium. Notice that the second task and the second transitions are invalid because first, the task has a duplicate name and transition leads to an existing task. So validator filters them out, having only nodes which are valid from model perspective in place. Identifier on its own loads corresponding identities which are JSON object stored in a separate file, fully synchronized with the Langium documents through LSP event handlers. It maps each validated AST node by its name to its identity. In case of task list language, tasks are mapped first, and transition afterwards, since transitions are identified by their source and target tasks. As a result, identified model is constructed, which is in fact a heart of LMS. These models are further exposed to external consumers, which is in this case GLSP server, through RESTful API. The updates are computed and sent on every cycle of document update in Langium. This is performed through HTTP to server sent events mechanism. The GLSP server itself consumes the LMS model and combines it with diagram-specific information managed by GLSP. As an output, the G model, which is a source model for diagram, is constructed. External modification is rather currently straightforward and hard-coded. Through LMS modification API, the request to modify the source model comes to the LMS. LMS computes text edits, changes to be applied on the Langium document, and send them to Langium language client to apply changes in the editor directly. This is done through LSP protocol. But the API itself is more powerful because it operates on the LMS model, not on the AST. So I believe here is time for a quick demo. You can also follow later by the, play around later by the link provided here. So, having an IDE launched in a browser, I have shopping, I have textual model for task list and a diagram. Let's create some sort of short shopping list. Notice that as I type, the corresponding nodes appear in the diagram view. I can also use LSP actions to modify text because it's normal textual language. Let's see. Pages. I can also rename nodes. They'll be updated on the diagram. Also, when I click on different nodes, the corresponding, when I click on different text constructs, the corresponding nodes on the diagram gets centered. Saving is synchronized when I save the text model, the diagram was saved as well. Interesting stuff is if I type invalid models here, for instance, you see duplicate transition, duplicate name of the task, unresolved transition, invalid task without a name. They will not appear in the diagram because they are filtered out by a validator. Let's switch now to the diagram editing. I'll disable the auto layouting, which is, by the way, is done with ELK, Eclipse layouting kernel. Let's create some sub-elements for our shopping list. We have fruits and vegetables. Let's create 2 tasks. Oranges. And let it be potatoes. And for instance, I accidentally put incorrect transition. So now I can also change that, and the change will be reflected in the textual model. Having that in place, I can also freely delete unnecessary tasks, let's say, have some truly redundant stuff, I can easily select it and delete, and all the incoming transitions to these tasks will get deleted. Also, again, saving is synchronized when I save the diagram. The textual file is saved as well. Finally, let's see how it works with validation. Here I have a little bit more complicated model. I have, let's say we have a language validation rule that content may only start from an uppercase, and that the task obviously cannot reference itself. Here, I have these validation errors in the text editor, but what's also cool, what's also cool is that these errors are propagated to the diagram with GLSP validate model handler. By clicking on this icon, I have corresponding icons appeared with the same validation messages as on the source document. So this basically concludes my demonstration. Let's sum up. What is done? First, I implemented the proof of concept model with task list language designed for task list notation for GLSP, and connected language server with graphical language server, so that now we can edit either representation independently, and they will be fully synchronized bidirectionally. Second, generic algorithm has been developed to convert Langium AST into the LMS model and expose it through an API, the API. What's missing, however, is generic algorithm for external modification. Currently, this is hard-coded for the task list. It would be lovely to have it generated out of Langium grammar. Ideally, of course, it should be generated out of Langium grammar, I mean the whole LMS infrastructure, so that Langium DSL grammar can serve as an EMF declaration. So, on that, I conclude. Thank you very much for your attention. Do you have any question? Okay, I see already a lot of good. In the text representation, this is the first question. I see limited syntax of the programming language, for example. How would a for loop look in this language, and how it would be represented in the diagram? Well, this is currently not target of this work. It could be presented differently. Well, I mean, whatever notation you develop. The point here, though, is to connect text language with graphical language. The idea is that it can be done for basically any language, any notation, provided that the corresponding generic algorithms are fully designed. Okay, question 2. Excellent approach and great demo, thank you. How do you deal with preserving white space in text or incremental layout on the graphical editor in case of new elements? Well, I'm not actually understanding the part about preserving white spaces. Ah, yeah, okay, so you mean by external modification. Currently, it's hard-coded. Again, it would be nice, of course, to design a full algorithm to not have to hard-code it, but have changes applied smoothly, automatically. Regarding the layout, LMS sends every update of the model to the consumer, and GLSP server actually rerun the automatic layouts every time it accepts the new update or the new model. So basically, currently the whole diagram gets relayouted. This is done again, as I said, with HTTP2 push events, which is also called server sent events. This is from the topological part. Have I answered your questions? Are there any other, perhaps? I see that's all then. Thank you very much for your attention.